particular topic on the basics of dynamic programming. So I'll provide you the link in the description box, you can check it out. Now see, coin exchange problem is also of two types. One type of problem we will discuss in this video, and second type of problem we will discuss in next video. Fine. So the problem is you are given different types of coins, or you can say coins of different denominations, like 1 rupee coin, 2 rupee coin, 5 rupee coin, 10 rupee coin, something like this, and you are given a certain amount. Fine. Now the question is, or the problem is, you have to find out in how many ways, or you can say the total number of ways you have to find out in which you can make the change of the given amount using the given coins. See, let us take one example. Coins are given 1, 2 and 3. Denomination of 1, 2 and 3. And here see, the condition is you have infinite supply of coins. That is very important. Here the condition is infinite supply of coins you have. Fine. Denomination of 1, denomination 2, denomination 3, you are having coins of these denomination, and the amount given is suppose 5. Let us take one example. You went to a shop and you maybe bought something, and in return maybe a shopkeeper has to give you 5 rupees, but he is not having a 5 rupee coin. He is having only 1 rupee coin, 2 rupee coin, and see, although practically it is not possible to have 3 rupee coin, but when we are solving these type of question, then we assume we have 1 rupee coin, 2 rupee coin, 7 rupee, 10 rupee and something like this. Fine. Now how he can give you 5 rupees using these coins, and the condition is he is having infinite supply of coins. So first thing is he can give you 5 1 rupee coin. That is fine. 1, 1, 1, 1 and 1. Or second way is he can give you 3 1 rupee coin and 1 2 rupee coin. The total is 5, 2, 1, 2, 3, 4, 5. That is also fine. Or third way is he can give you maybe 1 1 rupee coin and 2 2 rupee coin. That is also 5. That this also makes a total of 5. 2 plus 2 plus 1, that is 5. Or another case is maybe he can give you 1 1 2 1 rupee coin and 1 3 rupee coin. That is also will make a total of 5. 3 plus 4 plus 1, that is 5. Or another way is maybe he can give you 1 2 rupee coin and 1 3 rupee coin. Now I guess there is no way he can give you these coins to make a total of 5. So total ways to make this sum using these coins is 1, 2, 3, 4 and 5 ways. Now we will take one more example and we will solve that problem using dynamic programming. See, one is this kind of problem. I have already told you there are two types of coin change problem. One is this kind of problem, you have to find out total number of ways. Second problem is coins are given, different denomination of coins are given, certain amount is given. You have to find out the minimum number of coins to make this amount using these coins. So if we'll solve that problem using the same example, then suppose coins are 1 2 3, total is 5. Now you have to find out the minimum number of coins to make this sum. Now if we choose this set, then how many coins we need to make this 5 1 2 3 4 5 5 1 rupee coin. Fine. If we choose this way, then how many coins you need to make a sum of 5 1 2 3 4 4 coins. 3 1 rupee coin and 1 2 rupee coin, something like this. Now out of these ways, minimum number of coins are this one. If you choose this set, 2 coins you need to make this total. Second problem is something like this. You have to find out minimum number of coins. But in this video, I am going to tell you how to calculate the total number of ways. In next video, we will discuss how to calculate minimum number of coins. So let us take this example. We are given this coins of denomination 2, 3, 5 and 10. And the amount given is 15. Now you have to find out the total number of ways in which you can make a change of this amount using these coins, and the condition is you are given infinite supply of coins. Fine. Now using dynamic programming, how to calculate this thing? See, we can use recursion also, but what is the drawback of using recursion? That we have discussed in previous video. Fine, because the time complexity would be exponential, 2 raised to power n. And why so? Because the sub problems are computed again and again. We are not going to store the result, but if you use dynamic programming, then we will store the intermediate result and we will use those results whenever the same sub problem comes in future. That is why dynamic programming will take less time. Okay, and number of computations will be less, obviously. Now see how to solve this problem using dynamic programming. We are going to generate a table. Why so? Because we are going to store the results in that table so that we can easily use those results, those intermediate results. Fine. So this way we are going to write the coins, the denomination of coins. We are having 2, 3, 5 and 10. Fine. Generally we write these denomination in ascending order. Okay, and this way in this side we are going to use this amount, but we will not write 15 here, because we are going to divide this problem. In dynamic programming we are going to divide the complex problem into sub problems. So we are going to divide this sum into smaller sums. So we are going to start from 0 until 15 we will write here. Okay, 0, then 1. Now we have divided this complex problem into simpler sub problems, like from 0 to 15. You can take this one. Suppose at time when we are supposed to make the change of this amount 1 using these coins, at some point of time we are going to make a change for this amount using these number of coins, and ultimately we will reach to solution of the complex problem. Okay, so here 3 simple steps are there. First is exclude the coin, next is include that new coin, or third is add this first and second. Now how to use these steps I will show you in this case. At starting, suppose we are at I value. Suppose this side is we are taking I value, this side we are taking j value. Okay, now when we have only coins of denomination 2 and the sum is 0, you have to make this sum. Is there any way? Yes, there is a way, one way. And which is that way? Because if you do not choose this coin of this denomination, then obviously you will make sum of 0, na? Don't use any coin. So there is one way. So in this column we always write 1, 1 and 1. Below this 0. Fine, because if we do not choose any coins, then obviously we are going to make a sum of 0, na? That is why we are taking here 1. Now come to this point. Now the sum is 1. Can you make this sum using a coin of denomination 2? You can't. Fine. So here you will write what? 0. Okay. Now next is 2. Now see, sum is 2 and you have to make this sum using a coin of denomination 2. Is there a way? Yes, we can do. If we choose 1 2 rupee coin, then obviously we can take sum of 2, na? So that is why we have one way. Can you make a sum of 3 using coin of denomination 2? If you choose 1 2 rupee coin, then you cannot make. If you choose 2 2 rupee coin, then also sum is 4. You cannot get 3 in any case. So there is no way. Okay, simply you will write some. You can make this 4. Yes, we can make. Only one way we have. Which way is this? 2 and 2. 2 2 rupee coin you choose and you will make a sum of 4. So that is why we are having only one way. Can you make this sum 5? No. Can you make this? Yes. This no. This yes. 0 1 0 1 0 1 and 0. Fine. Now I value is increased. We are having now coins of denomination 2 and 3. Now the new coin is this 3. Fine. Now here we are using this rule, but simple rule is, or you can say the shortcut is, if coin value is greater than the sum, then just copy the above value. This is the simple trick. If this coin value is greater than the sum value, then simply just copy the above value. Okay, this is the simple rule. So coin value is now 3. Here we have already taken 1 is less than 3, so we simply copy this value from the above cell. Here we copy this value, fine. Here is 1, here also we have 1. But now when sum is 3, now this 3 coin value is 3, sum is also 3. So this condition is not true. Now you cannot copy the above value, you have to calculate that value. Now to calculate this value, you have to follow these rules. First is, if you do not include this coin, then how many ways are there to make a sum of 3? Just check the value of the above cell, 0 ways. So you write 0 plus, if you include this coin, then how many ways are there? How to calculate that thing? If you are including that coin, then you have to do just one thing. Just reduce this coin value from the amount. We are calculating value for this cell. Now check out this amount, 3. You are calculating for 3. So you just do this 3 minus this 3 and we got what? 0. Now when you are working in this cell, just go to that column having value 0, having some value 0, and just check out this value. This value is 1, so we simply add 1 here. So this value is 1. So you simply write here 1. So if you are having coins of denomination 2 and 3, you can make a sum of 3 with one way only. And which is that way? Obviously you can see, if you choose one coin of 3, then you can make this 3. So one way is there. Fine. For this one, first way is exclude this coin. Exclude this coin, then you have only the coin of denomination 2. So we will just check. You are calculating for this cell, so you just check the upper value 1. You will write 1 plus. If you include this coin, then what will happen? Then the rule is what? After including this coin, just you have to do, check this value, amount value 4 minus this value 3, and we got what? 1. So in this same row, go to the column having sum 1. Here we have 0, so 1 plus 0 is 1 only. Fine. These are simple rules. For 5, now how to calculate for this 5? Having 0 plus 5 minus 3, that is 2. So in this row only, go to the column having amount sum 2. Here we have 1, so 0 plus 1 we are going to take here 1 only. So here what you will write? See, above value we have value 1. Simply if you do not include, then just copy the above value 1, then plus. If you include this coin, then how many ways? 6 minus 3, that is 3. So in this same row, go to the column having sum 3. Here also we have 1 plus 1, that is 2. Okay. Now what is there? 0 plus 7 minus 3, 4. Go to the column having 4. Sum 4, 1. 1 plus 8 minus 3 is 5. Now this row 5. 1 plus 1, that is 2. Now here 0 plus 9 minus 3 is 6. In this row, go to the column having sum 6. 0 plus 2 is 2. Here 1 plus 10 minus 3, 7. 1. 1 plus 1 is 2. Here 0 plus 11 minus 3, that is we have 8. 2 plus 0, that is 2. 1 plus 12 minus 3, we have what? 9. So 2 plus 1 is 3. 0 plus 13 minus 3 is 10. We have 2. 1 plus 14 minus 3 is 11. This one is 1 plus 2 is 3. Here 0 plus 15 minus 3 is, I guess, 12. So here we will write 3 plus 0, that is 3. So let us take this case also. Now we are going to fill this cell. Now here we have 5. So this coin value, or you can say this row value, is greater than this 1. So we will write just 0, here also 1, here also 1, here also 1. If you are here we are having 5, so from 0 to 4 you will write the same value which are in above cell. Now for 5, how to calculate? Simply follow these rules. Exclude this coin, fine. Now if you are exclude this coin, then in how many ways you can make a total of 5 using only the coins 2 and 3, denomination of 2 and 3. How many ways are there? One way is there only. Just copy the value of above cell, just take the value of above cell. Plus, if you include this coin, then how many ways? If you include this coin, then the funda is simply do 5. Just we are going to calculate for this sum, na? So from that sum, just minus the value of that denomination. 5 minus 5, that is 0. So in the same row, you will go to a column having sum 0. Here we have 1, 1 plus 1 is 2. Okay. Now I hope you can fill this table like this. So using that method, you just fill this table. Just check out for this one finally. See, here the amount is 15 and denominations we are having coins of denomination 2, 3, 5 and 10. Now this 15 is, you can say, this greater than this 10, so we will not copy value from above cell. If this value is greater than that W value, then we will copy. Otherwise you have to apply this rule. If you do not include this 10, if you exclude this 10, then in how many ways you can get this total using these coins? Obviously 7 ways. Just copy the value from above cell. Plus, if you include this, then how many ways? Then the method is just do this amount minus the coin value. 15 minus 10 is 5. And just in the same row, go to the column having value 5. So here we have 2, that is 9. Okay. So how many ways are there? 9 ways. The answer would be always in the intersection of last row and last column. So 9 ways are there. In 9 number of ways you can make a total of, you can make a change of this 15 using these coins. Now we are going to write the logic for this one. See, suppose I am taking a 2D array, okay, where you are going to store the solution. Suppose this cell is there. So I am taking name of this is A and I and J. This cell is A of I value is this one. This side we are going to take I value. I value would be from 0, 1, 2, 3. Coins is the array, 1D array we are taking. Okay, and here we are taking J, this J value from 0 to 15 we have taken 0 to that amount. Okay, now and this array I am going to take name A, a 2D array where we are going to store this results, the intermediate results. Fine. Now you have to apply 2 for loops. What are those for loops? One is for this I and one is within this I, within this row. I is for row. Within this row we are going to check the values of columns, na? So first of all for row, then within this row for column. For 2 loops we are going to take. First thing what you have to do is simply we have just put 1, 1, 1 here when the amount is 0. So maybe simply you can do A of I and column value is this 0 and simply put 0. Sorry. So here simply put 1 at all the places, and somewhere you find that they'll start here from 0 denomination. 0, then 2, then 3, then 5 and 10. So if 0 denomination you take, then what you will do? Here only you will take 1, otherwise 0, 0, 0, 0, 0, 0. Because if you do not have any coin of any denomination, obviously then you cannot make the sum. You can only make a sum of 0 only. Okay. So now next thing is you have to apply the for loops. One for loop is for I. I is equal to from 0 to I less than equal to, you can say that if you are taking this array name is coins, then you can say that coins dot length and I plus. Then within this loop we are going to take a loop for j, for these columns. So j is equal to 0 and j is less than equal to this amount, given amount and j plus. Now you have to apply the logic. How you filled these cells? Okay, simple rule is what? If if this coin value, this row value is row value is greater than this amount, then simply copy the value from above cell 5. So just write down, just check a condition. If coins of I is greater than j, then what you will do, simply a of I of j is equal to a of I minus 1 and j. I minus 1 means from the upper row copy the same value, else you will do what? Else you have to apply the formula, the exclude, include and then add 1 and 2. Fine. Now see, else a of I j is equal to, what we have done, else, see suppose this one was 5, till 0 to 4 we have copied same value, else what we have done, this value plus 5 minus 5 plus this value from 0th column, 1 plus 1, that is 2. Now what you have done is a of I minus 1 and j. See, a of I minus 1 is this one and j is same row. So this value plus what we have done, a of same row, I would be same, but we have changed the column. Column value हमने क्या उठाई है? Column value is this one. So column value is this j minus, what we have done, this 5 minus 5. So j minus, see here j value is this one, this 5. Okay, now from 5 we have minus this value, j minus coins I, because coins is this name of array and I value is here 2. So we have just done 5 minus 5 and just taken this value. Okay, and we just add these two values. So this is how the main logic is. I am not saying that this is the complete and exact program, but this is somewhat the logic you will write when you will code this thing. Okay, so in next video I am going to discuss with you the second type of coin change problem. Okay, so till then, bye bye, take care.